Hey guys, today we're going to be going over sinusoids and phasors, so let's get straight into it. So there's three things we need to define a sinusoid. Three things to define a sinusoid. Okay, and those three things are the amplitude, the phase, and the frequency. So let me write out the typical cosine expression. You have A times cosine of omega t plus phi. And so here we have the amplitude, here we have the phase, and here we have the frequency. Alright? So now that I have that out of the way, let's talk about phasors. Okay? Let's start off with Euler's identity. Right, and so what that says is if we have e to the j times some theta, we get cosine theta plus j times sine theta, right? And so what we see here is that we have a real part and we have a complex part, right? So let's get the visual representation of this. Okay, let's say we have we have x equals 2e to the j pi over 4, right? So let's get a grid or coordinate, and the x-axis will have our real part, and the y we have our imaginary. So basically, to graph this, we would have pi over 4 is 45 degrees, and 2 is our radius. So we see here that this length is 2, and this theta is 45 degrees, or pi over 4. Alright? So we can write that as x equals 2ej pi over 4, or if we use Euler's identity, we get 2 cosine pi over 4 plus j sine pi over 4. If you plug that in, we get root 2 plus j root 2. And so we have here an exponential form, and here we have a rectangular form, because here we can see that this is square root 2, and this over here is square root 2. Almost like an ordered pair or a coordinate point. And so we can use this. Let's say we have a phasor, or not a phasor, we have e times j times omega times t. We have a time component. So as time passes, the phasor will rotate, or the value will rotate around this axis, where we have imaginary, real. Maybe at time equals 3, it'll be over here. Then after some time, it'll be over here. It just rotates with time. So we can see that we have g times omega t, or yeah, and then e times j, e j phi. So here we can see that this is our frequency part, and this is our phasor. You can think of a phasor as the starting point of a sinusoid. It has the info of both amplitude and phase. So, if we know the phasor and we know the frequency, we can get the sinusoid that it talks about. So let's say we have a frequency of 200 radians per second, and then we have a phasor of 2e times j pi over 4. To get the time expression for this, we get the amplitude. If we look back here, we have a times cosine of omega t plus phi. So we have our amplitude, which is 2, right? And then we have our frequency, which is 200. And then we have our phi, or our phase, which is pi over 4, or 90 degrees. Or not 90 degrees, 45 degrees, sorry. And so I've shown you before 2 forms. We have the exponential and the rectangular. But we also have, let me write them all out. We have that exponential form. We also have this form, you might see. So this part is dictating the amplitude, and this part is dictating the phase. We call this the polar form. And then we also have the rectangular form. So this is exponential. Both of these are polar. And this is rectangular. Let's do an example. Let's say there's a voltage at node A, and the voltage at node A has a phasor of 6e, e to the power of j times pi over 3, and has a frequency of 100 radians per second. You need to find the time domain expression. So we have 6e to the j pi over 3, and we also have a frequency of 100 radians per second. So let's just plug them in to our cosine formula, which is a cosine omega t plus phi. Plug those in. We get 6 times cosine, because that's our amplitude, as you see here. We have our amplitude, and then we have our frequency times time, and then plus our phase, which is pi over 3. And then typically you'll see written in degree form. So we can also write it like this. And this is our answer. Both of these are correct, but you'll typically see the phase in degrees. So next, let's go over phasor arithmetic. So let's say we want to add or subtract two phasors. So we could, first we need to go to rectangular form. Then add like terms, then back to polar, if you would like it like that, at least. So let's say we have 2e j pi over 4 plus 3e j pi, or no, let's do 2 pi over 3. We want to add these into whatever the result is. So let's remind ourselves of Euler's identity, which is e j theta equals cosine theta plus j sine theta. If we use that for this, we've already done this. It's root 2 plus j root 2. If you plug into here, we get negative 1 plus j 3 root 3 over 2. And so we have our real parts and then our complex parts. So we're going to add complex to complex and real to real. And so that gets us root 2 minus 1 plus j times root 2 plus 3 root 3 over 2. Plug it into our calculator, we get something approximately equal to 0.4142 plus 2.1443 j. And if you want, we can turn this back to polar. We get our amplitude, which is, to find the magnitude, we have let's go back to our representation. Here we have the imaginary part. Here we have the real part. If you want to find the magnitude or the amplitude, we just take the square root of r squared plus I squared. And so plug that into your calculator using 0.4142 as our real and 2.1143 as our imaginary. We get 2.18394 as our amplitude. And then for our phi, we need to use the tangent using SOHCAHTOA, right? So tangent equals opposite, which is I, over or adjacent, opposite over adjacent. So tan inverse of I over R. And if you plug it into your calculator, we get 79.066 degrees. Okay, now let's talk about multiplying or dividing. So all we gotta do is multiply or divide if we're dividing the amplitudes, and then add or subtract the phase. Right, so back to our original example where we had 2ej pi over 4 and we had 3ej 2 pi over 3. Let's say we want to multiply these. We would just multiply the amplitude, so we get 6. And then if we're multiplying, we're adding. So we're going to add these together, and that should be, or let's solve this. So 3 pi over 12 plus 8 pi over 12. So that gets us a phase of 11 pi over 12. Now let's say we wanted to divide. We have, write them out again. Divided by 3ej 2 pi over 3. In this case, we divide our amplitudes. So you have 2 over 3. And then we need to subtract our our phases. So you would have, let me not write this in polar because that would take some calculations. Negative 5 pi over 12. And that would be the result of our division. So now let's talk about adding sinusoids of same frequency. Okay, so let's let y1 of t equal a cosine omega t plus phi 1, and we'll have y2 of t equal b cosine omega t plus phi 2. Notice how these two have the same frequency, all right? So let's turn these into their phasor or exponential forms. So we get here, we have a, or let me write this in black, a times e to the jwt times ej phi 1. And then here we have b ej omega t times ej phi 2. All right. Let's say we want to add these. We're going to add them. So we would have ejwt phi 1 plus bjwt times j phi 2. All right. So basically what I'm trying to show you is, or hold on, let's get to it later. I'm going to factor out the frequency part. So when I do that, we're left with the frequency part on the outside, and the inside we have EJ phi1 plus B EJ phi2. And you'll notice that these are just the phasors of both. So we can just add them using our method of adding phasors. So you can see that when adding cosines or sines of same frequency, the result has the same frequency with added phasors. Okay. Same frequency, and all you gotta do is just add the phasors, right? So let's do an example. Let's add these two. So we have 5 cosine 200t plus 50 degrees and y2 of t with 3 cosine 200t plus 90 degrees. So if you bring these phasors out, we have a phasor of 5EJ 50 degrees and 3EJ 90 degrees. If we add them, we get a rectangular form of 3.2394 plus 6.83022, something along those lines. You find the amplitude, which is the real part plus the imaginary part squared, all rooted. We get 7.5496. And then for our phi, it's the inverse tan of I over R, and that equals 64.808 degrees. So put them together, y total equals 7.5496 cosine, remember it's the same frequency, so 200t plus 64.8008 degrees. And that's our answer.